Good morning, geometry students. This is Mr. Lane coming again at you from OHS High School for the iPad Initiative class. This is section 6.4, Properties of Special Parallelograms. Hopefully you remember what a parallelogram is from the last section or two. Opposite sides would be parallel, and we know a lot of things about parallelograms, which will hold true to the special parallelograms we talk about today. So make sure you read through the objectives, the why, answer number 5 in your notes, and be looking for that secret word as we go along through this lesson. A few things to define real quick. The special parallelograms we're going to talk about today. The first one is a rhombus. A rhombus is an equilateral of 4 congruent sides. A rectangle will be a quadrilateral with 4 right angles. And then a square is going to have the 4 congruent sides and the 4 right angles. So the first one we're going to get into some detail with is the rectangles. It says on the first theorem here that if a quadrilateral is a rectangle, then it is a parallelogram. So if we know that it has 4 right angles in it, then we also know it's a parallelogram. If a parallelogram is a rectangle, then the diagonals are congruent. So now we know that the diagonals, the full length, they don't bisect each other. Well, they will bisect each other because it's a parallelogram, but this is saying that the actual full length of the diagonals are going to be congruent. Alright, a woodworker constructs a rectangular picture frame so that JK, let's label that as we go along here. JK right here would be 50. And then JL all the way across here would be an 86. And we're supposed to find HM, so this right here. Okay. Well, we know that the diagonals are going to be congruent, so that's going to make this 86 for KM. So if KM's 86, then halfway across that, all we're going to do is divide that by 2, and we're going to come up with 43 centimeters for HM. Now, some other problems that they might throw at you, we would have known that this is a right angle, so we could have actually found what that side was using Pythagorean, so something else to keep in mind. Alright, regular geometry students, looks like 2, 4, 10, and 12. iPad Initiative, you should be up and ready to go for you. Alright, properties of the rhombus. If a quadrilateral is a rhombus, then it is a parallelogram. If a parallelogram is a rhombus, then its diagonals are perpendicular. So that's something new here that the rhombus has. So if we draw these in here, notice that they're going to intersect and form a 90-degree angle right there at the intersection. Alright. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So anyways, this angle right here would be bisected, making this side congruent to this side. Also, you'd have this angle bisected, making this angle congruent with this angle. Alright, it says TV WX is a rhombus. Find each measure. Well, we know that opposite sides are congruent, so it looks like we could find B very quickly. So let's say 3B plus 4 equals 13B minus 9. So it looks like we need to subtract the 3B, which will give us 10B over here. Add the 9, should be 13. So divide by the 10. So B would equal 1.3. Okay. Let's see. And then, we know that the rhombus, that's going to intersect to be a 90-degree angle, so we could take 14A plus 20 is equal to 90. And we need to subtract the 20, which will give us 70. So 14a equals 70. Let's divide by the 14. So a, let's see, would be 35 halves, which is 17.5. Okay. So probably what we need to do here is go ahead and take and plug in to find what each side would be, and then plug in the A here to figure out the angles. So let's see if we can get the calculator up here. Accessories, calculator. Alright, so we've got 3 times 1.3 equals plus 4 equals 7.9. So all the sides would be 7.9. And then let's go ahead and figure up what that angle would be. So let's clear. Let's go 5 times 17.5 equals, and then we gotta subtract 5 from that, 82.5. Alright, so we got a double 82.5, so that's 164, 165 for the big angle. Okay, of course all of these are going to be 90 degrees in here. So if this is a parallelogram, this angle would be supplementary with the 165, which would make it a 15 degree angle, making each one of the small ones 7.5 degrees. Same thing over here. These would match up with these over here. And I think we've found every single side and angle then. Alright, let's move on. Regular geometry, 6, 14, and 15. And then I think, let's see, a square is a rhombus, rectangle, and parallelogram, so it contains all the properties of all three. Show that the diagonals of a square, E, F, G, and H, are perpendicular bisectors of each other. So what we're going to do here is we're going to first off show that the slopes are opposite reciprocals of each other, and then we're going to show that the midpoints are the same for both those segments, and that will show that they were perpendicular bisectors. So all we're going to do to start with is count. We're going to count the rise over the run from E to G first. So let's go ahead and do that. We go up 1, over 1, 2, 3, 4, 5, 6, 7. So this one would have a slope of 1/7. And then let's see, from H to F we'd go up 1, 2, 3, 4, 5, 6, 7 and over 1, and it's slanted downward, so it would have a -7 slope. So if they multiply to a -1, which -7 times 1/7 would, then that's going to equal -1, making those two opposite reciprocals, so they would be perpendicular to each other. Now, I think we're just going to use the midpoint formula real quick. So F has coordinates of 1, 3, and H has coordinates of 0, 1, 2, 3, 4. So 0, -4. So if I add the x's together, that would be 1 plus 0 divided by 2 would be a 1/2. And then if I add the y's together, that would be 3 plus a -4. Giving me a -1 divided by 2 is going to be a -1/2. And we want to do the exact same thing for E and G. So E's coordinates are 1, 2, 3, 4, -1. -4, -1. And G is going to have the coordinates of 3, 0. So again, instead of learning some big long formula, we just add the x's together, which is going to give us -1 divided by 2, give us -1/2, and then add the y's together. It's going to give us a -1/2. By the way, f was at a negative, making that a negative. So their midpoints are going to be -1/2, -1/2, so they're going to be the same, making that the perpendicular bisectors of each other. So let's move on. Bam, 8 and 16 from that page for the regular students, iPad Initiative students. Yours is on the Lumen site. Alright, we're going to actually jump past this one. I don't think you guys will have to do any of those. So I think that's going to wrap up our lesson for today. Fun little activity here. Why don't you take a screenshot of this, go ahead and answer it in a Edge Creations. Trying to drag these up to each one that they fit underneath each column, and send that to me also. I'll give you a couple of extra credit points for doing that. Today's secret word, hoppity hop, kangaroo. Just kangaroo for the secret word today. Send it to me spelt right, receive your 2 points. So this is Mr. Lane signing off from OHS High School. Catch you on the next time.